Problem number 5 reads, a stunt driver wants to jump a car over 5 trucks parked side by side below a horizontal ramp. The height of the ramp above the top of the trucks is 2 meters and the horizontal distance he must clear is 25 meters. What must be the minimum horizontal speed of his car if he is to successfully clear all 5 trucks? Let's take a look at that jump. Here we see the car make a successful leap across the trucks. The information that we're given is that the car starts at a vertical height of 2 meters above the top of the trucks. It must leap a horizontal distance of 25 meters. So the car must fall then a vertical distance of 2 meters while it travels a horizontal distance of 25 meters. The problem is to determine the minimum horizontal velocity of the car in order for it to be able to do this. All right, that is the problem. Give it a try. Our problem is to find V0x. If we look at the motion of the car in the x direction, the only equation among our equations for projectile motion that involves V0x is the equation that the displacement x is equal to V0x multiplied by the time, where the time is the time that it takes to travel the distance x. If we solve this equation for V0x, we have V0x then is equal to x divided by the time. Now we do know x, it's 25 meters, but we don't know the time. If we could find that time, we could solve our problem. If we look at the motion of the car now in the vertical direction, say the y direction motion, and if we allow the car to start at the origin of our coordinate system, in other words, y0 we allow to be equal to 0 at time 0. Also, the car starts with an initial velocity in the y direction of 0 since it is moving only in the horizontal direction. The car must fall in the time that it takes to go 25 meters horizontally. It falls a vertical distance of 2 meters. Let's let our displacement y then be equal to 2 meters at that time. And we will put a negative sign on that to be consistent with our convention that downwards is negative. So we know y. We also, of course, always know the value of g, that this is minus 9.8 meters per second. And what we would like to find out is the time t, because that time is exactly the same time that it takes for the car to travel horizontally. So that's the question. If we go back and examine our equations then for the motion in the vertical direction, we find that the displacement y is equal to y0 plus v0y times t plus 1/2 g times t squared. And if we substitute the values that we have in this equation and solve it for t, we have y is minus 2 meters is equal to y0, 0 plus v0, which is 0 times t, plus 1/2 minus 9.8 meters per second multiplied by the time squared. And if I solve this for the time squared, I would get t squared then is equal to minus 2 meters divided by 1/2 of minus 9.8, which is minus 4.9 meters per second, This gives you a value of 0.408 seconds squared. If I then take the square root of that, we would get that t is 0.639 seconds. Now we want to take that time and put it back up here, and we can solve for v0x. This was 25 meters divided by now 0.639 seconds. And this comes out to be 39.1 meters per second. All right, that must then be the minimum horizontal velocity that the car has in order to clear this row of trucks in a horizontal distance of 25 meters. All right, that is our problem. Let us move on now to the next problem.